Hi everyone, I'm back one more time, maybe one last time, on this series of porosity measurement. In the previous videos, if you have seen some of the previous videos, I've talked about what porosity is, giving you a little definition, why we even test porosity. In some of the others outside of the overview, we talked more specifically about conventional benchtop instruments, the Gurley instrument, the Sheffield test, for instance, the Benson test. Today, or for this video, what I'd like to do is talk to you about a non-conventional method that is an online porosity analyzer. If you can imagine for a moment a world where you can collect a continuous stream of this porosity information in real time. You have the means to control furnish or monitor furnish changes, monitor furnish lot changes, and the like. Control or monitor refining. As you're refining blades starting to age. You can actually see that happen. Their structure of this paper is going to change when you have different conditions in refining. Controlling your vacuum, or again making sure that the vacuum system is working properly. Reduced grade change times. There's been excellent response from customers who've taken 15% shorter grade changes. The times to make grade changes start out with a certain level of porosity measuring, going through a grade change, and in this particular case, maybe in less than 15 minutes, they've got the grade running back where it originally was. Or it could be at a new target. There's some work that's involved behind the scenes, of course, to get to that point. But almost every process or every step along that paper machine prior to the dry end of the paper machine will affect the structure of your will affect the structure of your web. There's a number of different things that occur upstream that you can control, that you can monitor, that you can adjust, that will change the structure of that web. It'll open that web up, it'll tighten that web up, either way. But once you get on grade, you're monitoring that porosity, so you can monitor the structure of that sheet and continue and make that sheet as consistent as possible. Now, this is a non-conventional or non-standard test, of course. You can see I only have bits and pieces of this product here. It's a fairly good size piece of equipment, but you can see where this could in fact have some really good results. You have good correlation to your lab information. Benson milliliters per minute. We do an R-square on something like that, and it's probably better than 90%, maybe even up to 95%. We do the same correlation with a Gurley test. We look at the Gurley results from our benchtop equipment, correlate to the response that we're getting off of the machine. We run a correlation, and R-squared 90% or better. So obviously there's some work behind the scenes in order to get this system set up to match or to, let's say, simulate your benchtop equipment. But you are getting orders of magnitude more data than you've ever had before, and you can see these changes if you have a furnace change, if you have something that goes wrong with the refiner, if you have something that goes wrong with the vacuum. You can see these changes almost instantaneously. You can see them almost as fast as that machine is running. So to give you an idea how this system works, we mount the system, we mount a measurement head underneath the web. Typically, it's underneath the web of the machine. We put it, attach it to a tower that's mounted very firmly, whether it be on the machine floor or whether it be on a machine scaffolding, but something that's very, very firm. We mount a measurement head on top. We adjust it so the web of the sheet comes in contact with the measurement head. And then we do some other tricks. In other videos, we talked about some similarities between the different methods. One of them being we need some means of clamping or fixing the measurement area that we're testing, that's under test. In this particular system, we have a number of different types of measurement heads that we can utilize on this system. But we have essentially, we have two sets of rings that are grooves that are cut into the measurement head, similar to this here, very similar to this here. We have an outer ring that we create a vacuum that will actually hold this sample tight to the surface of this measurement head as the web is moving. And then we have an inner ring. This area here is used to draw air through, in most cases, draw air through the sample. We draw air through, and again, we talked about some similarities or some let's say, necessary features or functions with the benchtop equipment. We have to have a way to create a pressure drop across this surface. We do that with a vacuum. In most cases, like I said, we do that in the vacuum. Some tighter grades, we want to be able to draw that sample down with the outer ring. We want to hold it in place, and then we want to draw air through the web as it's traversing downstream. So we mount it under here. This measurement head comes in contact with the web. This material is, the surface of these measurement heads are made of some very durable, low friction coatings, and we've experimented around with a number of different types of coatings. Some are less, let's say, susceptible to static. Some are less susceptible to scratching, to marring. All different types of designs of the measurement head, all different types of coatings for the measurement head. So we have this outer ring. Typically, this is probably more of a standard design as compared to this piece here. This might be designed or is designed for a narrow web situation, okay? We want to cover, in the case of these narrow webs, we want to be able to utilize this particular device. We couldn't use this type of a measurement head on a 12-inch, something smaller than a 12-inch or 11-inch wide web. We need something more narrow to accomplish that and still seal the sample to the measurement head and be able to draw that air through. So we have this mounted underneath the web. This measurement head is actually in contact with the web. I don't know if you can see my shadow here, but again, the outer ring is drawing the web to the measurement head to seal it tightly. The inner ring here, in our case, is actually drawing air through from the atmosphere through and then through our measurement system, and then we use it to evaluate and send that information to a control box. That control box could easily be connected to a DCS system so that you can interface it with your mill system. Correlation work would be critical if you're looking at using this data to ship your paper by. But it's not imperative that you do the correlation. Really, what you need to do is you establish the levels of measurement signal that you can get out of the system and look at that level and use that in conjunction with whatever you're looking at in the laboratory, so that now you establish that you've reached your level of porosity based on your laboratory equipment. I can go ahead and I can run this information. Typically, the operator, or the owner, the user of this equipment will in fact correlate to their benchtop equipment. So they can, again, we talked a little bit about using the same language when we're talking to our customers, when the customer is talking to us. It's much easier to talk to your production people if they already understand what your laboratory equipment is doing and as far as the response on the instrument is concerned. So if you correlate to your benchtop equipment, you use basically the same language out to the production people. Hey, there's some change where the sheet is tightening up, the sheet is opening up, something upstream is happening, or maybe it's intentional, like intentional when in the case of a grade change. We are monitoring some other processes, okay? You're looking at possibly adding some broke to save yourself a little bit of money. You see what happens with the broke. Sometimes you add some broke, the sheet tightens up, you get the decrease in the porosity. Now you make some adjustments based on that. This unit, as I mentioned, it's non-standard. However, it's been used on a number, right now I know that it's been used on a number of different grades. I know it's been used on cigarette paper. I know that it has been used on lightweight coated paper. I know that it's been used on some sack paper. There's a wide range. I know that it's also been used in some cases on some lightweight board stock. So there's all kinds of uses for this device, and with a high degree of success. So my last hurrah, talking about non-conventional testing, but in real time, getting this information in real time, getting that back out to the production people in real time so that they can continue to make this web as consistent as possible, your quality stays as consistent as possible, and your customer base stays as happy as possible. So I do appreciate you listening in to this last bit of information on porosity. Certainly appreciate you taking a look. If you have already done it, looked at some of our other videos. And again, if you have any questions out there you'd like to discuss, you have some issues, you have some questions about conventional instrumentation, you have some questions about online instrumentation, certainly don't hesitate to give us a call. We love to talk and give you as much information as we can, be as helpful as we can. We like to help you make better paper.